The last part we learned today is about the sources of energy, and energy conversion and conservation. First, chemical energy. This diagram of a thermal power station shows how chemical energy is converted to heat energy at the boiler, then converted to kinetic energy at the turbine, and finally converted to electrical energy at the generator. In boiler, fuel is burned to convert chemical energy to heat energy. The heat energy is used to boil water, producing high-pressure steam, which drives a steam turbine connected to an electrical generator. The low-pressure exhaust from the turbine passes through a steam condenser and is recycled to the boiler, where it is heated up again. The fuel can be fossil fuels such as coal, petroleum, natural gas. The fuel can also be biofuels, for example, fuel from plant, such as wood, charcoal. The advantages of chemical energy are cheap, easy storage. The disadvantages of chemical energy are byproducts cause air pollution, for example, acid rain. Supply will run out. Next, hydroelectric energy. This diagram of a hydroelectric power plant shows how potential energy of stored water is converted to kinetic energy at the turbine, and finally converted to electrical energy at the generator. The dam stores river water in an upstream reservoir. Water released from the upstream reservoir flows through a turbine, spinning it, which in turn activates a generator to produce electricity. Next, solar energy. In this first diagram, solar energy is converted to heat energy. The thermal panel is installed on the rooftop facing the sun to collect solar energy from the sun. Cold water is pumped into the water pipe at one end of the thermal panel. After passing through the long pipe and the thermal panel, the cold water is heated up, and hot water is collected at the other end of the panel. That's one simple way to harness solar energy. To convert solar energy to electric energy, the process is in the second diagram. The solar cell is connected to electrical components using electrical cables, forming an electric circuit. When there is sunlight, the solar cell converts solar energy to electric current flowing in the circuit. The advantage of solar energy is no pollution. The disadvantages of solar energy is high initial cost. Next, geothermal energy. This diagram of a geothermal power station shows how heat energy underground is converted to kinetic energy at the turbine, and finally converted to electrical energy at the generator. Cold water is pumped down to several kilometers deep underground, where it is heated up by the hot rocks. The heated water is pumped back to the surface, and some of the hot water is transformed into steam. The steam drives a turbine connected to an electrical generator. Next, nuclear energy. Nuclear energy is a type of stored energy in radioactivity substances. It is converted to heat energy, then converted to kinetic energy, and finally electrical energy. There are two types of nuclear energy: nuclear fission and nuclear fusion. In nuclear fission, heavy elements, such as uranium, are split into light elements. In nuclear fusion, light elements combine to form slightly heavier elements. In both cases, an enormous amount of energy is released in the process. Examples of nuclear fission is nuclear bomb, nuclear power station. Nuclear fusion occurs in sun and stars. A nuclear power plant is a thermal power station in which the heat source is a nuclear reactor. The nuclear reactor is the heart of the station. In its central part, the reactor's core produces heat due to nuclear fission. With this heat, a coolant is heated as it is pumped through the reactor and thereby removes the energy from the reactor. The heat from nuclear fission is used to raise steam, which runs through turbines, which in turn power the electrical generators. Next, tidal energy. Tidal energy is power produced by the surge of ocean waters during the rise and fall of tides. Tidal energy is converted to kinetic energy at the turbine, and finally converted to electrical energy. This is a diagram of a tidal barrage, which is a dam-like structure used to capture tidal energy. When the tide is high, water enters the river through the turbine and generates electricity. When the tide is low, water flows out to the sea, turning the turbine and generating electricity. Next, wind energy. Kinetic energy from the wind is converted to mechanical energy at the turbine, and finally converted to electrical energy. There are other forms of energy, such as electrical energy, light energy, sound energy, wave energy, but we will not discuss about them today. The last topic for today is about energy conservation: reduce, reuse, and recycle. First, reduce the amount of material needed. For example, reduce using disposable cups, plates. Second, reuse those that are already available, so that we don't need more energy to produce new materials. For example, use old newspapers to clean windows. Third, recycle by chemically reprocess waste materials into new and useful products. For example, paper, scrap metal, aluminum can, glass bottles. This is the summary of what we have learned today. That's all for today. Thank you for the effort to learn with me. Stay tuned for more interesting lessons. See you next time. Bye bye.